Namaskar. Let's try a few questions. Important point is these all are frequently asked questions on your entrance examinations. Watch your entire video, check your answers, comment number of answers you got correct. So let's go through few questions. You can pause the video here and you can check the questions. You can try solving the questions. I am going quickly, but you can pause whenever you wish. Try to solve these questions. These all questions are asked in one or the other entrance examinations, and these are actually the doubts that uh, the people who feel that they can ask me have asked me. So, this is the doubt clearing session, I would say, for many of the people who are watching this particular video. You can pause yourself, you can pause the video, you can try solving the questions. Okay, so there are total 7 questions that I have flashed on the screen. Now, all these questions are from basics of geometry and you can say mensurations, 2D figures. To solve these questions very confidently, what you need is to master the following concepts. First, 2D shapes. Second, quadrilaterals and their properties. Third, polygons and their properties. And fourth, formula for counting of diagonals. Now, these are the 2D shapes. When I talk about triangle, what would be my area? Let's say this is side A, this B, and this is C. So, what would be my perimeter? So, perimeter shall be A plus B plus C, whereas area of a triangle shall be 1/2 into base into height. Now, this is height and this is my base. Okay. Now, when I talk about rectangle, if the length is L and breadth is B, then perimeter of the rectangle shall be 2L plus B, whereas area shall be L into B. When I talk about a square, square has 4 equal sides. So perimeter will be 4A and area will be A square. When I talk about a circle, here perimeter is called circumference. Circumference is 2 pi r, where r is the radius. This is the center and this is the line which is joining any one point on the circle. That's r. Okay, and area will be pi r square. Value of pi is 22 by 7, which is approximately 3.14. And this is the quadrilateral. Now, if it is A, B, C, D, then perimeter of the quadrilateral will be A plus B plus C plus D, and we'll find so many types of quadrilateral in my next slide. So now quadrilaterals when we talk about, so very common type is parallelogram and second is trapezium. Okay, now trapezium is having one pair of parallel sides like this and another pair of non-parallel side, right? Whereas parallelogram is having when two lines, parallel lines intersect with another two parallel lines, the enclosed figure is formed is called parallelogram. Okay, now when we talk about parallelogram, if it is this is A, this will be A. If this is B, this will be B. And when we talk about the angles of the parallelogram, this angle shall be equal to this angle and this angle shall be equal to this angle. Apart from that, other property is the adjacent angles shall be of 180. That means sum of the adjacent angle. That means if at all this is X and if this angle is Y, then X plus Y shall be 180 degrees, right? So this is what is very, very important. Now, when we talk about rhombus, a parallelogram with 4 equal sides is called rhombus. Now, the one very important difference between parallelogram and rhombus would be rhombus has two diagonal bisecting each other at a 90 degree. That means this will equal to this and this will equal to this and this angle will be 90. Whereas in parallelogram, diagonals bisect each other. That means this is equals to this and this equals to this, but this angle is the angle between them where they intersect is not equal to 90. Similarly, when we make rhombus straightened up and which can form 90 degrees all four angles, that becomes square. And when parallelogram we straighten up, it becomes rectangle. So all the angles over here will be 90 degrees. Okay. Now, diagonals here bisect each other but not at 90 degree. Diagonals here bisect each other at 90 degree. When we talk about the trapezium, diagonals of trapezium do not bisect each other and definitely not intersect at 90 degree. When we talk about kite, kite is a special kind of a quadrilateral which is not symmetrical at all sides but only one side. But we can create symmetry like this. Okay. Now, if this is one diagonal, the other diagonal intersect at both the diagonals intersect at 90 degree, but they do not bisect each other. So that's what is very, very important to remember. In kite, this side shall be equal to this side and this side shall be equal to this side. So these are the basic understandings about the 2D shapes of the quadrilateral. Now, let's revise everything. Okay. Now, let's revise. When we talk about quadrilaterals, all the quadrilaterals have 4 sides, 4 vertices, 2 diagonals, and angles add to 360 degrees. When we talk about parallelogram, opposite sides and angles are equal, diagonals bisect each other, adjacent angles is summed to 180 degrees. Rectangle, all the right angles, equal diagonals bisect each other. Rhombus, all sides equal, diagonals perpendicular, bisector of each other. And angles opposite to each other will be equal to 180 degrees. Squares inherit all rectangles properties and rhombus's properties. Trapezium, exactly one pair of the parallel sides. Base angles and diagonals are equal if isosceles shaped. Kite, two pair of adjacent equal sides, diagonals perpendicular, one bisect the other, symmetric shape. So these are the basic properties of all the types of quadrilateral that we have discussed. Once again, revise it in the other form because these are very important properties. Square, sides equal, angle 90 degree, parallel sides pairs are 2, diagonals equal and perpendicular, both rectangle and rhombus. Rectangle, sides are not equal, angles are 90, all the angles are 90, 2 pairs are parallel sides, diagonals equal and bisect each other. This is a special kind of a parallelogram. When we talk about rhombus, equal sides, all angles are not 90. Two pairs of parallel sides are there in a shape, perpendicular and diagonals perpendicularly bisect each other and all sides equal. Parallelograms, sides are not equal, angles 90 degree नहीं बनाते हैं, parallel sides two pairs होती हैं and diagonals bisect each other. It's a general form of a quadrilateral. Isosceles trapezium. Sides are not equal. Angles do not make 90 generally. Exactly one pair of parallel lines present. Equal diagonals but do not bisect each other. Do not intersect at 90 degree. Symmetric trapezium. Kite adjacent pairs are equal. That means these two adjacent pairs and these two adjacent pairs are equal. Angles do not make 90. Parallel side कोई नहीं होती है, none of the parallel sides. Diagonals perpendicular, one is bisected. That is, this one will be bisected by the other one. Symmetric across main diagonal. I hope the basic understanding about the 2D shapes are clear. Now, when we talk about polygon, polygon means it's an enclosed figure, 2D shape, made up of a straight line segments which are called sides and connected end to end. Basic rule is the shape must be closed and have at least 3 sides. That means 3-side polygon is triangle, 4-side let's say square or parallelogram or quadrilateral or trapezium, anything. Okay. 5 sides will be pentagon, 6 sides will be hexagon, 7 sides will be heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon. Okay. So these are the classification based on the number of sides of a polygon. Now, where do we see such kind of polygons in our real life, right? So let's say equilateral triangle, right angle triangle, all these things are triangle. Quadrilateral, when we talk about, there is square, rectangle, trapezium. Pentagon, when we talk about, it's a regular pentagon that we see. Hexagon, let's say honeycomb cell is something like this, which is hexagon, right? When we talk about octagon, traffic stop sign, if you notice on roads, it will be in the shape of octagon. Some more examples like triangle is traffic signs, rectangle is mobile screen, square is tiles, chessboard, pentagon is building structure sometimes, maybe pentagon in USA if you know. Hexagon is beehive cells, that is honeycomb cells. Octagon is stop sign, decagon is coin, decorative tiles, etc. etc. So these are the real life examples of polygon. Now, important properties of polygon, extremely important. Please do not forget this particular formula. Number of diagonals, that is n into n minus 3 by 2, where n is equals to number of sides. Sum of the interior angles will be n minus 2 into 180 degrees. Each interior angle shall be, see, sum of the interior angles are n minus 2 into 180 degrees, then each interior angle would be divided by n to it, right, for a regular polygon. Each exterior angle will be 360 degrees by n, because sum of all exterior, if I ask you sum of all exterior angles of polygon would be what? It is going to be 360 degrees, right? So each exterior angle will be 360 by n degrees. N is number of sides of a polygon. Let's say if at all I have pentagon, right? So if I draw a pentagon like this is my interior angle and this is my exterior angle. So all the exterior angle over here add up to 360 degrees. So what would be one exterior angle? That will be 360 degrees divided by n. N is over here is 5. So that is 360 degrees by 5. I hope I'm very, very clear. Now number of triangles are n minus 2 by drawing diagonals from one vertex. In the sense, if at all I have a pentagon and the question is asked to me how many triangles I can make from this pentagon. So I can select this two vertices and this is the third. So this is one triangle. If I take these two vertices and this is the third, then I can make this second triangle. If I can fix these two vertices and this is the third, then this is the third angle, triangle. Then I can fix up these two and take this is fourth one. So accordingly I can make number of triangles. So how many number of triangles I can make by drawing diagonals from one vertex, that is n minus 2. Now symmetry, regular polygons have multiple lines of symmetry. Perimeter, sum of all sides in regular polygon is equals to side into number of sides. Area depends on shape. Use specific formulas for triangles, squares, etc. So this perimeter means if I talk about pentagon and this is A, 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 then sum of all sides will be side, that is A, and pentagon has 5 number of sides, that is 5. So it is going to be 5A, right? So that's how it goes. Let's move to the next point. Now diagonal count. It's very interesting. Now see, if I have triangle has 3 sides. I'll put this 3 value into this particular formula. So what would I get? 3 into 3 minus 3 divided by 2, that is 3 into 0 by 2, which is equals to 0. Now let's say this is triangle. I can't make any diagonal, so answer is correct. Diagonals are 0, right? Now quadrilateral. I'll put 4 minus 3 by 2. So I shall get 4 into 1 by 2, that means 2, right? So quadrilateral, if at all this is a quadrilateral, this is one diagonal, this is another diagonal. Pentagon, if I talk about 5 into 5 minus 3 by 2, that means 5 into 2 by 2, that means 5 diagonals. So if I have a pentagon, so I can have this diagonal, this diagonal, this diagonal, this diagonal. I have 4, 1, 2, 3, 4, and this is 5. So I would be having 5 diagonals. Similarly, we can go for hexagon and octagon. Try it out yourself. Calculate with the help of the formula, that is n into n minus 3 by 2 for hexagon and octagon both. And check whether you get 9 and 20 or not. If you get 9 and 20, tell me in the comment section that you understood how to find the diagonal count in any polygon. Write a diagonal in the comment section if you can understand how to find number of diagonals in any polygon. Now one important rule, that is for any triangle with sides A, B and C, the following inequalities must hold. That is A plus B, which is greater than C. See, basically, if this is a triangle and if it is A, B and C, then sum of any two sides of a triangle must be greater than the third side. That means A plus B should be greater than C, A plus C should be greater than B, and B plus C should be greater than A. Then and then only the triangle is possible, otherwise triangle is not possible. It cannot be equal to, like A plus B cannot be equal to C, A plus B cannot less than C, but A plus B has to greater than C only. If this is the case, then only the triangle is possible, and this should be checked for all the possible pairs. Now the similar way, if there is a quadrilateral and the sides are A, B, C and D, then sum of any three sides should be greater than the fourth side. That means A plus B plus C should be greater than D. B plus C plus D should be greater than A. C plus D plus A should be greater than B. And D plus A plus B should be greater than C. If this is the case, then and then only the quadrilateral is possible, otherwise it is not. Now, another important concept is line of symmetry. So now understand, the line of symmetry is an imaginary line that divides a shape into two identical halves. It creates the mirror image, and this line can be vertical, horizontal, or diagonal. Now, order of rotational symmetry. The order of rotational symmetry is the number of times the shape appears identical to its original position during a full 360-degree rotation. Okay. Now, let's understand in a better way. So, when we talk about any quadrilateral, let's say square. So, this is the image. I can draw one horizontal line or a vertical line, one horizontal line, and two diagonal lines in a way that it creates symmetry, right? So, number of line of symmetry over here is 4. When you talk about rectangle, I can draw one vertical and one horizontal line. I can't draw diagonal line. This is not possible because they do not intersect. They do not create mirror image. Parallelogram, I can't create this, not diagonal. So there is zero line of symmetry. The similar way you check with rhombus, kite, trapezium, isosceles trapezium, and irregular quadrilateral, right? So please try these shapes and try to find the line of symmetry. Now, this is something different. That is the order of rotational symmetry. So, if at all I say this is A, this is B, this is C, this is D, I rotate it clockwise in a way that this A comes at a place of B, B comes at a place of C, C at a place D, and D comes at a place of A. Then also the shape will be identical. I can't understand if at all I don't name the vertices that I have changed its position. So it is having, if you check it, you will be having 4 such possibilities where the shape doesn't change and you rotate square on its axis. So order of rotational summary would be 4. Similarly for rectangle, if at all this is A, B, C and D, if at all I rotate it to the 90 degree, I'll get like this. D, A, B, C. Now this figure is not the mirror image or the similar image or the same image of A, B, C, D. That means it is not having the order of rotational summary in this position, right? If I again rotate clockwise for 90 degree, I'll get the same figure which it was earlier. So if you check that ways, the order of rotational summary over here would be 2. Similarly, order of rotational summary for rhombus is 2, kite is 1, parallelogram is 2, equilateral triangle is 3, isosceles trapezium is 1, hexagon is 6. You check it through. If you have any doubt, please let me know in the comment section. I'll make the more detailed video next time. But I think with this condition, with this understanding, you can go further. Now, this is a special case. When you talk about a circle has infinite line of symmetry. And order of rotational symmetry is also infinite. How? You can see, you can rotate in it into 360 degree. You will always find the same position, same shape as it was before. So order of rotational summary in the case of circle is infinite. Similarly, line of symmetry is also infinite, which you can see. Now, when you talk about oval, if I rotate it to 180 degree, I can get the same shape, but not in any other position. So line of symmetry as shown in the figure is 2, and order of rotational summary is also 2, because 1 is the original position and second is the 180 degree movement of the oval. Okay, by now I'm sure you are ready to solve all the questions. Watch the entire video for the detailed solution. Now, this was the very first question. Rectangle, kite, rhombus, pentagon, trapezium. How many of the 5 shapes above have diagonals that always cross at right angles? Now, let's revise, let's summarize what we have learned. So please focus on the highlighted ones. Rhombus has perpendicular bisector, means 90 degree. Square has all the qualities of rhombus, that is 90 degree of the bisecting diagonals. Kite has perpendicular diagonals, that is 90 degree, right? So we are very clear with the answer that rhombus, kite, that means 2. Option E, kite and rhombus has the diagonals which always cross at right angles. I hope I am very clear. Now, I am a shape in total of 14 diagonals. Which of the following shape I am? So let's go for a stepwise solution. Now, number of diagonals over here will be n into n minus 3 by 2. Now, n into n minus 3 by 2 is equals to 14, which is given in the question. I have just put down the values. N into n minus 3 is equals to 28. Now, n is multiplied here, which is n square. N is multiplied here, that is minus 3n. And this 28 is shifted to this side, which is minus 28. I think I have spoken something wrong. I am speaking once again. N into n, that is n square. N multiplied with 3, that is minus 3n. And this 28, which is plus on right hand side, came to left hand side, it became minus 28, right? Now, when I solve this particular formula, when I solve this particular equation, I do get n is equals to 7 or minus 4, right? If you don't know how to solve this, do let me know in the comment section. I will help you out with this as well. Now, when the value of n is minus 4 and I am talking about the polygon, so this is invalid. This result is invalid. So I am left with 7, and a polygon which is having 7 sides will be called a heptagon. So my answer is heptagon. Next question is, I think of a shape. The interior angles of my shapes are this. What shape could I be thinking of? First of all, I'll sum all up and I got 360 degrees. That means I know it's a quadrilateral. But when I see the option, all the types of shape that are given are quadrilateral. So I need to think one by one. So I'm taking kite. Kite is a quadrilateral with 2 pairs adjacent sides equal, 1 pair of equal angles which are between unequal sides. That means this and this, this and this angle and this angle will be same. Diagonals intersect each other at right angles, okay? Like this. This is right angle. One diagonal bisect the other. That means these are the properties, okay? So when I talk about it, this one or this one, okay? So this one is going to be 66, okay? This one is going to be 70, this one is going to be 70, and this one is going to be 154. So these two are going to be equal interior angles. Now this is not the case with rectangle because it has 90 degrees. This is not the case with parallelogram because parallelogram would be having like this angle and this angle same and this angle and this angle same, we cannot have three measurements of angle. So it's gone. Rhombus is also the same case. Now kite and trapezium. When I talk about the trapezium, what is the case there? That these two will make 180 and these two will make 180. Now it is not the case with this two and this two or any of the possibilities. So trapezium also rules out. It gets ruled out. So now I have only one option available, that is kite, and my answer over here is kite. I hope I'm very clear. You can revisit this particular slide. You can revise this question and go ahead. Okay. Now the next question is, how many different five-sided shapes can be found in the given diagram? Okay. So first of all, what should I do is, I'll give name to the various vertices. That is A, this is B, this is C, D, and E. Okay. Now I'll give this vertex a name as A, R, A. Sorry. Not this vertex. A already we have given. Okay. Let's say A, B, C, D, E. Okay. Let's say I'll give this E, F. E is over here. So I'll give F, G, H, I. Then over here, J, K, L. Now this and this as M and N, this and this as O and P, this and this as Q and R. Fair enough. Now, let's find out what all are the five-sided shapes that can be found in the given figure. So I can say A, B, C, D, E. You just focus on what I'm writing and try to check in the figure. O, F, I, Q, B, P, G, H, R, E. Then F, P, F, P, E, R, I. Okay. Then F, O, B, Q, H. Then I don't think F, O, B, Q, H can be possible. F, P, E, R, I. F, O, B, Q, I. Not H, I would say. F, O, B, Q, I. And then Q, B, A, E, R. I'll once again show it to you. Now see, A, B, C, D, E. This is one pentagon. I mean the five-sided shape. Now O, F, I, Q, B. This is another one. P, G, H, R, E. That is another one. Now F, P. Let me change this thing. Now let's say this figure. F, P, E, R, I. This figure. This one. Do you get that? This is also five-sided figure. I hope you understand. The same way, the opposite side. I shall go with G, O, B, Q, H. I think over here I've made it mistake. G, O, B, Q, H. Yes. So this is like this. This figure. I hope you understand. I hope you are clear. And lastly, it's Q, B, A, E, R. Yeah, this one. Let's say black one. This figure I'm talking. Okay, I hope I'm very, very clear, right? So, we had got in this way in total 6 five-sided figure, five-sided shapes. So, my answer is option D, 6. A square has rotational symmetry of order 4, which we can understand. This meant when it is rotated about its center, the same square is seen 4 times before it returns to its original position. That's right. So now look at the shapes given below. That is equilateral triangle, rectangle, regular polygon, oval and parallelogram. Now, how many of the shapes shown have the same number of lines of symmetry as they have order of rotational symmetry? So, let's check that out. Order of rotational symmetry, I would write as ORS, and lines of symmetry, I would write as LS. So, ORS here is 3, LS 3. ORS2, LS2, ORS5, LS5, oval ORS2, LS2, and parallelogram ORS2, LS0. So I have such 4 shapes where line of symmetry is equals to order of rotational symmetry. You can see very well from here, correct, 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 not going with the condition. So now, sixth question. Which of the following is a true statement? These are the 5 statements. You can pause the video here and go through it. I will make you check one by one along with me. So very first a triangle can have 2 obtuse angles. That's false. Why false? Because 2 obtuse angle, that means 2 angles more than 90, and sum of all the 3 angles in a triangle is 180. So when I have 2 angles obtuse angle, the sum would be always more than 180, which is impossible for a triangle. So first statement is wrong. So this is a wrong statement. Now second, triangle never have a pair of perpendicular lines. This is again wrong because a right angle triangle will be having. So this is false. Now third, a rhombus has 4 equal angles. Wrong. Rhombus has 2 equal angles which are situated opposite sides. That means 2 pairs of equal angles. Opposite angles are equal, not all angles are equal. So rhombus is wrong. Matlab rhombus has 4 equal angles. This statement is wrong. But please understand, you can have a question that square is a rhombus and it has 4 equal angles. So that is a special case. We cannot say a generalized statement true based on a special case, right? Now fourth statement, D. A trapezium always has a line of symmetry. That's false. A general trapezium or trapezoid does not necessarily have any line of symmetry. It is just that isosceles trapezium has. That means if at all I draw a trapezium like this, okay? Let me put it in a better way. Let me draw better. If at all, see. Isosceles triangle means what? A symmetric, isosceles trapezium means what? A symmetric trapezium where this equals to this and these two lines are parallel, right? But when I draw a trapezium like this, 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 so it does not have any line of symmetry, right? So this is not a generic rule, okay, for trapezium. So a trapezium always have a line of symmetry is not correct, but an isosceles trapezium always have a line of symmetry can be correct. But this statement is wrong. Now fifth statement, a kite's diagonals cross at right angles. That's true. The property of the kite which we have already talked about. So the option E is the correct answer for this question. Now next question. This question is also, every question that I've discussed in this video has been asked in one or the other entrance examination, and very importantly grade 7 examination, 11 plus examinations, various competitive examinations in India and abroad. Such kind of questions are being asked. Which one of the following sets of lengths cannot form quadrilateral? Okay, now see, A plus B plus C has to be greater than D. So now when I add 8, 9, 10 will be greater than 17. 5, 8, 10 greater than 15. 7, 11, 14 greater than 18. 9, 12, 15 greater than 30. But this is not happening here because 6 plus 7 plus 7 is equals to 20, which is equal to 20. That means 6 plus 7 plus 7 is not greater than 20. That means this quadrilateral is not possible. This way, option D is the answer. Only option D doesn't follow the rule, which is very important to make a quadrilateral. That is, sum of any 3 sides of a quadrilateral is always greater than the 4th side. I hope I'm very, very clear, and I hope this video was helpful to you. Like, share, subscribe, and comment. Thanks a lot.